Okay guys, what we're going to do in this video is we're going to go through an example of the force that is experienced by a moving charge in a magnetic field, right? So what I want to do first is go through with you one example that we haven't gone through explicitly in this class, and I want to go over with you guys because it takes a little bit of knowledge from Physics 1, so I want to make sure that everybody's on the same page here. So I have a question here that is, if I have a proton and it's at rest, okay, so this proton's at rest, and I want to speed it up to some very large velocity here, 2 times 10 to the 6 meters per second. Okay, how much voltage do I need in order to do this? Okay, so this part here is purely from Physics 1, and what we're going to do is we're going to define the work that we need to do in order to speed something up, right? So the work that we do changes the kinetic energy of whatever we perform work on, right? So this is whatever my final kinetic energy is minus whatever kinetic energy I started with. But because we're starting from rest right here, this is 0. Okay? We don't have any kinetic energy to start because we're starting from rest. If we're not moving, then we start with nothing, right? So this makes it very simple here, where all I need to do is find what's the final kinetic energy here, and I'll know how much work I need to do on this object in order to speed it up to this final velocity. Okay, so the way we do this is we just use 1/2 mv final squared. Let me go ahead and write this again. Okay, so this is the amount of work that we need to do. So we know the speed that we need to attain here. And the thing that we need to fill this in with is the mass. So one thing we're going to need here is the mass of a proton. And this here is 1.67 times 10 to the negative 27 kilograms. Okay? So we're going to define this way so that way we get work in joules. Okay, there's a few ways to do this, but we're going to find our work just in joules. And here we're going to solve for this, right? So we're going to do 1/2 1.67 times 10 to the negative 27, and then my velocity squared that I want here, so this is going to be 2 times 10 to the 6th squared. So if we go ahead and type this into our calculators, I'm doing this as well here with you, so if you're following along, what we will end up with here, just a moment, should be 3.34 times 10 to the minus 15. So, hopefully I'm right here. So I just plug this into my calculator really quickly. What I got here was 3.34 times 10 to the negative 15 joules. This is the amount of work that we need to do in order to speed up a proton from rest to this final velocity. Okay? So, we know the amount of energy that we need in joules, but we have also another way of looking at work when we're talking about accelerating something, accelerating charge in an electric field, right? So we know that the work done by an electric field is how much charge do we want to move, and then over what potential difference do we want to move this charge, right? So if we want to move a charge, let's say from 50 volts to 0 volts, well, it's going to do, it's going to accelerate. It's going to accelerate over this potential distance, this potential difference distance, right? And then we know the amount of work that we're going to end up doing. But these two here are the same. They're the same value in terms of the amount of work that we need to do. Okay, so what we're going to do here is we're just going to plug this in. We're going to go ahead and plug in the charge of a proton. This is 1.6. I'll go ahead and put it up here. Charge of a proton. is 1.6 times 10 to the negative 19 coulombs. Okay, so we have 1.6 times 10 to the negative 19, and our delta V is what we're looking for. So this right here, we're going to bring it on over, and we'll have, let's go ahead and just bring this right down here. Okay, what I can do is just bring this over here, and we'll just bring these guys together very simply. Okay, so you guys can see this. Now, all I need to do is solve for the voltage, right? So the potential difference that I need in order to do this becomes, okay, this is going to cancel out right here. And now we just need to solve for this in our calculators, right? So we've got our 3.434 times 10 to the minus 15. Now we just need to divide this by 1.6 times 10 to the negative 19. And we get that we need about, so our potential difference is approximately about 20,900 volts, right? So just rounded there at the end. So we need about 20,000 volts in order to accelerate a proton to what is to this very high velocity right here. Okay, so this would be how we calculate the amount of voltage that's needed in order to accelerate a charge through some field.